clear, right? Except there are no. So afterwards the model is converged. So the next thing is you are going to see the result. So the output from the model. And that's the thing that you are going to check how much of the household or how much of the space is increased, where they go and how the development happened in after 10 or 20 years. That's the thing you are going to test. So he will tell you how you will test those things, how you will see the files and how you analyze the results. It's okay.
So I think all you guys now have folders from 2025 to 38. So we know 2025 is the base year. So we do the calibration and everything in 2025. So then model runs and generates outputs for 2006, 26, 27 up to 2038. The two main files we are interested about is activity location file and also flow space I file. So the activity location file, let me open. So activity location file has the location of the activities in each zone and their quantities. So these are the utility values it uses to calculate the quantities. You guys don't need to worry about this. This is the calculation for the budget model calculation. They use these constants and utility values to calculate this quantity. So we are mainly interested about this quantity column, and we have the data for all the activities for the each zone. So for example, we need to check where the households are in 2026. So if you have filtered to households, it will give, for example, zone 1 here. I think zone 1 is downtown zone, city center zone in the Wuhan. So you can see in zone 1 we have 28,000 households in zone 1 in 2026. But if you go to the 2027 folder, it also have a file called activity location for the 2027. So it has the data for 2026. So if I filter the same household types here, and there is a quantity column also here. So if I check the quantity, then see urban households in zone 1, there are 31,000 households in 2027. But in 2026, we have 28,497 households. That means 2026 to 2027 in that zone, new 3,000 households moved to that zone. So you can do, because in some zones you get more population, some zones actually people are moving out to different zones which they have maybe accessibility depending on the inputs we are giving. For example, if you add a metro station in one zone, so that will actually attract the households. Maybe people who are living in different zones which doesn't have a metro will come to the zones which has a metro location, and so then the activity location file will give you the increase in that zone but decrease in that zone which doesn't have the metro station. So this also give you, this is for example households. If you check industries, so industry locations also very important when you do policy analysis in a region. For example, I can show you the commercial services of. So, for example, to find out where the employees are in each year, we can use this commercial or non-residential activities, and we can analyze how these non-residential activities are going to change through years. So then it will give how the employees are going to change in each zone, which is very important when you are running the travel model in future years, because travel model needs where the employees and where are the households are, where the population are. So then you can generate the schemes. One of the main outputs from PECAS to the travel model is this file, because it is giving you where the activities are, which is the households, and also the industry location, which is the number of employees. So, do you guys have any question about this file? Yes.
Yeah, please, about the location. Now, we realize that from the 2026 to 2021, there has been a shortage in, I think, about 2,000 or 3,000 differences. Now, and you said these 3,000 difference is giving an indication that the people are moving to a different zone.
Yes.
Now, in this situation, if you do the summation of the zones, are you going to have the same values as compared to the previous years? Or
No.
would there be an increment?
Yeah, because this activity location file actually allocating the total amount of households to the zones. The total amount of households actually increase each year, because population increase means total number of households are increasing. So the total need to be different because it is coming from the activity totals, but the distribution can be changed.
Another thing is like growth factor, you know that how much percentage of growth each year, right? So they grow based on that growth factor. They are not just randomly increased. If suppose here in the base year you had 1 million, the growth factor is 1%. So the next year plus the 1 million plus the 1% of growth factor will add. The total should be there equal to that one. It's just not randomly generating. It should be based on that growth factor, how much of growing each year.
Okay, my other question is that the model, does it consider in terms of, let's say we are talking about urbanization, therefore people are going to travel. Maybe for instance, I wasn't in Wuhan, and last year I just came to Wuhan. Now, is the model going to give an account of those who travel out from a different, maybe province to Wuhan, and the exact place they are locating in the Wuhan city, and also those who move out from one zone to another zone?
Yeah.
Is the model able to, give us any indication as far as these two situations are concerned?
Yeah, so that's actually coming from the economic model. So people actually, for example, if people are coming from Beijing to the Wuhan, it need to be calculated by the economic model. So it's like working like this. For example, if people coming to Wuhan means Wuhan need to be attractive. So, for example, we are running now a model for the Alberta. So, city of Edmonton, they are planning to have 2 million population in 2065. So currently it has 500 population, 600 in 2016. So what we do is we run the model and check how much population is growing in the city of Edmonton. But people who are coming from outside, which is actually immigration, or people who are going out, we need to use those numbers in the economic model to calculate the activity total value for each year. Because PECAS cannot decide what is actually happening. If you give the total number for the Wuhan, that is coming from the economic model. But if you have the imports or export for the labor, for example, if people are moving out to another provinces to do the work, that means there are no jobs available in Wuhan to do the work. So in that case, you can have an export function to represent these people who are moving out. So then model will consider those amounts as people who are moving out. So we can do that. This also, the economic model also very important to get this calculation to find out how much people are moving into the Wuhan and out.
More questions? Okay. So this is very important file when you do some analysis, and also it's very important when you do policy analysis and doing the forecast for the future years. So another important file is the floor space I file. Floor space I file actually has the floor space quantities for each year, for each space type in each zone. So you can see here we have the data for each T set, for each space type, what is the quantity in this zone. So it's important to identify here in the floor space I file, we will not see a reduction. So we will not see a floor space is going down, because households can going down, but floor space every time, because we are constructing the space. If you are demolishing the space, it will go down, but most of the time what we do is we develop the space quantities in the zones. So this file actually gives you how the space quantity is growing in each zone for the each space type. So for example, I will show you here. So for zone 1101 in the 2026, we have 1.6 million square meters of residential space in this zone. So let's check what will happen in 2027. So it has 1.8 million. So that means 200,000 square meters were added to that zone. Because these space quantities actually also depend on what is the residential price for these zones, which is actually coming from the AA module, because AA module calculating space prices for each zone for each space type in each year. So we use these prices to find out how much space we need to develop in the next year. So every time, so if the price is very low, the model will not develop any space. So but price is high, it will develop space quantities in the zones. That's what I think. You had a map, right? That's it.
Yeah.
That 3D map. That's it. One we show in the
morning, right?
yeah. Do you have the equations? I can show them how to check the equations. This is, for example, gives you is actually it's not what is it? Yeah, so for example, this is the space what we had in 2008 for the Wuhan model, and so we had at the same site. So here 2028 we have this much of space in the Wuhan. As in the city center there are high space quantity, but when we go up to 2030 the space is increasing in all the zones, and it follows the same pattern which is actually developing more space near the city center. So the main function we use to develop these space quantities in the model is the function we use to calculate how much space quantities need to be added in each zone. So this function has a price called base price and base factor and the scale factor. This is the function we are using to calculate how much space quantity needs to be added for each zone. So this base price is very important because the model will only develop space quantities if the price is higher than this base price, because the developers will not develop space if the price is low, because the price is very important for the developers. So if you have less price, if you develop the space, if you cannot sell it, they are not getting any benefits. So developers interested about the price, that's why this function mainly depends on the price. So but the growth, the addition factor mainly depend on the base price as well, because if the price not go beyond this base price, the developers will not develop the space quantities. So we have this function for all the space types in the model. So we have 6 or 7 space types. So you can see this is a function for the residential, and this is the, for example, function for the office space. So here you can see the base prices are different for each space types, and the parameters also is different for each space type. So actually before running the model we need to calibrate these functions to using the observed data. For example, in a region you can find out how much new development happening in the zones and what are the rank values for each of those zones. So then we can actually fit this equation to these observations, and we can estimate these parameters based on the observed data. So we are using these functions to generate the space quantities in the model. So those are the space quantities you are actually seeing here. So which actually makes sense, because most of the time the prices are very high in the city center, so that developers come and develop more space in the city center. So these are the two main files actually we used to do most of the time the analysis of the policy, and also when we do the forecasting. So Do you have any questions on this file? So right, everybody understood it. Okay.
I want to ask, for example, in the year 2027, the floor space I is generated from the 2026
It is 26 prices.
prices into the AA model.
Yeah, we use the 2026 prices to generate the space for 2027.
The input is the price of 2026.
Yes.
And it included into the AA model.
Yeah. So
SD
SD module.
SD model.
So SD module then develop the space for 2027. So then what we are, after we develop the space for 2027, AA model will run for 2027. So then it generate the prices for 2027, and SD model will use the 2027 prices to generate the space for 2028. So then AA model runs 2028 and generate the prices, and the SD model use the 2028 prices to generate the space for 2029. Yeah, this works like that. This circle is a loop
Yes.
going through time.
So, can you also explain, like you can open the 2027 folder and there are like more than 20 Excel files, right? Folder.
Yes.
Can you explain which of them are generated by AA model?
Okay.
Which of them
Yeah,
are
yeah, sure.
SD model?
So in the model, the main inputs actually are in all years input folder.
All the parameters.
All the parameters.
Parameters are in this.
Yes. So for example, in this activities I file, we have what are the activities we have in the model and the dispersion parameters we are using for those activities. So, and because these are the main activities in the model, so you can see households are here, industries are here, agriculture, and exports and imports are here. And the two main parts is the activities and commodities, right? The commodities are in also commodity parameters also inside the ODS inputs folder. So you can see the commodities are labor and space and also the products you are using and services. So you have for all the commodities, we have these dispersion parameters and the transport cost coefficients for each commodity and the schemes they are using inside the model. So we need to give these values before we run the PECAS. So that's one file, and the next file is the histograms I file. So histograms I file we use to find out the trip distributions inside the model. So it have different bands. For example, this band from 0 to 0.2, 0.2 to 0.5. So model calculate how much money is flowing between these regions. So I will go to the output file as well later, but this is the file we define the bands for the trip lengths.
And these bands are in kilometers.
Yes.
If you say this one, right?
Yes.
In kilometer, then if it's time, then it is in minutes.
And I think there is the other distribution.
Yeah. The output, we have an output file also from histograms. I will show you, which has the outputs. This is output because input is only the triplex bands.
And I guess there you must include parameter or test
This special parameter. It's in the commodity side file. Here.
Oh,
Yeah, these are the parameters used to calculate actually the flows. But in the histograms file, we define the bands for the flows. How much, what are the, how many trips are going to travel between 1 kilometer to 2 kilometers. So, but we need to give as an input these bands, because otherwise model cannot understand what are the bands you need. Because if you are interested about only the long distance trips, you can give, oh, I need the outputs for 20 to 30 kilometers. I'm not interested about 0 to 2 4 kilometers trips. I need only 10 to 15 kilometers. So you, based on what you need to define these bands in this file. Yes, histograms are. And this is the ST parameters file, which I explained in the ST module. So we are giving the base prices and what is the base factor and the scale factor in this file. So these are actually the function parameters which I showed you here. So these parameters we are going to include in this ST parameters file for each base. And another important file is this flow space supply I file, which actually calculates the vacancy rates or how much space is going to be available in each year. Because if the price is high, we need to use 100% of the floor space quantity in each zone. But price low means most of the houses are vacant. So there is a vacancy rate. So these functions actually calculate what is the vacancy rate for the model in each zone based on the price. So these functions actually, the definitions of these functions available in theoretical formulation, which you can actually download. I think you guys have the theoretical formulation for this model. You can actually download it from, I will give you the website. Theoretical technical document about the equation we have in the model. We are for hbspectro.com. It's not connected to the internet. Yeah, if you go to this website, there's a folder called PECAS. So you can download all the documentation for these equations, infinite equation model and ST module from this website. So just click and you can download these ones. So
and I also want to know, you can go to this
which one? This one?
the last one. Yes. Why the two numbers like
-1 means we are applying for all the zones. This is actually for the coding. In the PECAS code, if you put the -1, that means I'm going to apply this function for all the zones. For example, if I put the 101 here, the PECAS module only going to apply this function only for this zone. That means if you have the data, you can define this function for by zone as well. But most of the time we don't find the data for zonal level. That's why we put -1. But if you have the data in zonal level, you can specify this function for each zone as well.
So in this situation, in this -1 situation, the total constraint of space is applied to all the
Yeah, this this equation is going to apply for all the zones. Yes. But if you have a different function for different, for example,
For different zones, you need to define average.
yeah. So if you have a function specifically for city center, you can use the city center zones and use that the second function to the city center zones using this column.
What about this? If I want to define the city center as a township, and there's others, all the others zones I need to be the same. So define.
Yeah. So -1 means it is going to apply for all the zones. So you can keep this -1. So if you put 1 or 1 here, it's not going to apply the function, this function, into this zone. So then, if you define the function for city center, assume this is city center. So then you need to have -1 again here. Actually, you can copy this whole row and paste in here and put -1, right? So then it is going to apply this function for all the zones except this one. Yes, that's how the script works. So then the other important files, that's the main files you need to worry about the inputs parameters. So then we'll just go for the outputs. So let's go to 2025 first. So you know actually locations right now, and this is also an output file. This actually giving you the size terms. It's kind of complicated for you guys because we are using some term called size terms inside the model, which is based on the floor space quantities available in each zone. So this file actually have the size terms for each activity. We actually use this file only for troubleshooting. If there is a problem, if a model crashes or something, to find out what is the problem. This file actually we don't use for any of the analysis we are doing. So activity numbers file actually have it defines the number for each activity. This file is same for all the output years. It's not going to change as well, because if you define a number for each activity, it's going to be same for all the years. So activity summary. So activity summary has it's also output file which has so activity summary has the composite utility for each activity for whole region, because you have a composite utility for each zone for each activity. Also you can calculate the composite utility for whole region as well. So for example, if you are doing analysis and if you need to check, utility mean actually the dollar amount of money value for each activity you have. So if you are comparing two scenarios, the positive difference means you have some benefits. So you can have the benefits in zonal level, also in the regional level. Maybe you have some negative utility in some of the zones, but if you get the summation for all region, it can be positive. So this is actually getting the composite utility for all region. So activity totals I is an input file for each year, which is actually, which I explained earlier, which actually define how the economy grows. So here you need to tell the model how much population you are expecting in 2027, how much industry will grow in 2027, something like that.
How do we get these?
These values normally generated by the central banks and maybe the economics departments in a region. They actually have a plan for the future, how much, because everybody know what is the population growth. You can do some calculation to find out that. So you can use the population growth to find out number of households in the future years. And this industry growth actually coming from the GDP growth. So if you are expecting 6% or 7% GDP growth every year, you can find out these total numbers using the GDP growth values from the census or the forecasting done by central bank or whatever the organization we have. Normally in Canada, we get this information from can get it from the federal bank. Also, there is a special department in each city and each provincial government who do this forecasting. This is a different type of forecasting. It's actually economics. We use, because PECAS is economic model, we need the economic inputs. And this is the schemes file, which is also an input to the model, because in the base year we can give the schemes we are going to use in the model. But if you are going to generate the new schemes, for example in 2030, you are going to put the new schemes into the 2030 folder. So if you put the 2000 schemes in 2025, model will use the 2025 schemes for all the future years until you put new schemes in the between years. So if you put a new schemes in 2030, model will use the 2030 schemes after the 2030. So when you integrating these three models, which is the sector allocation, space development and travel model. So what we do is we run the model, let's say you run the model from 2025, and in 2030 you can use PECAS outputs to generate the schemes for the travel model. You can use PECAS outputs to run the travel model and generate the schemes, and we can put the schemes into the 2030 and start the run again. So it's very important to understand this is an input to the model, but in the future years we use PECAS outputs to generate these schemes also as inputs in the future year. So this commodities is a utilities also an output file which has the composite utilities for each commodity in each zone. So and also we have this data for buying and selling separately. So this asset utility value is the utility value for example, it has this utility value for selling agricultural products in zone 1, buying agricultural products for zone 1. The composite utility value is 0.7. So this is
is this the utility used for the next year? Okay.
no, this is a theoretical formulation. This is not, we are not using it for the next year. This is actually current year output, current year utility output. So we calculate it for all the activities, utility values, and also for all the commodities in zones. This is the composite utility for the commodities for each zone, for each commodity. Definitely, these composite utility values is going to affect to the prices of the current year.
It's sort of accessibility, the composite utilities, accessibility for all those type of commodities.
Yeah, it's like an attraction
Yeah.
of the for this commodity in this zone. So, for example, to buy the agricultural products in this zone, it has this much attraction. But for example, let me fill the agricultural products.
The cost is same, that's why the utilities are same.
Yeah, so here we put to understand here. So you see that values are different. It is a small difference, but we use these values to calculate the attraction. So for example, this one has, you check the last three numbers, 883, and this one has 884. But this is negative value, but this means this is the highest value. So you can see this zone 11144 has the highest attraction for the agricultural products, which is also a rural zone, I think.
Yes.
So most of the time we have the agricultural products in the rural zones. So we have a high attraction to exchange the agricultural products in the zone 144, because agricultural products is there. So people are going there to buy the agricultural products. So it has a high attraction. Another important file is, output file is this exchange results file, which is actually giving you the prices for each commodity in each zone. So for example, here you see, we go to the space, it's very familiar to explain the residential space. So here it gives us the, for example, residential space, what is the price of the residential space in zone 1. So if you need to analyze how the price changes through time or between two scenarios, you can use this file. So it gives you the prices for each commodity in each zone and what are their prices are. So this is also output file, also very important file, but SD model uses these prices to calculate the floor space quantities in the next year. So this output file is used by the SD space development module to generate the floor space quantities for the next year. So floor space I explained. So the histograms file, which also very important. So histograms file gives you the quantities of trips for each commodity. So for example, in histograms I file, we saw these bands, right? So histograms file gives you the quantity for each of these bands. So then, and also it calculates, for example, here from 0 to 0.2, how much money is flowing from 0 to 0.2. And model also calculates what is the average between point 0 to point 2, and he's saying most of the trips between 0 to point 2 are average is 0.09. So this also calculate what is average between these ranges and give you the average length also here and the quantity values here. It's also very important to understand these quantity values. Here you can see for agricultural products, people are traveling, because here is the highest number, 590 million. So most of the trips, if you need to buy agricultural products, most of the time you need to travel between the average trip length you travel to buy an agricultural product is 15 kilometers. So this file gives you this information, which is very important when you calibrating the trip lengths, because we are changing the dispersion parameters and try to calibrate what is the average trip length you travel to buy agricultural products. So so make use file is also an output file which actually gives you each activity how much quantity, how much commodity consumed and made by each of the activities. So here you can see agricultural operation activity actually making agricultural products, and this is the amount it was produced for whole region. So you can find out for each activity how much commodity it is produced and is consumed in this form for whole region.
You define this table, right?
So this file for the base year, this base year we need this file, which is we call aggregate economic flow table, because it defines the base year each activity how much it produces and how much it consumes, and the future years model is actually generating this file, which is also an AEF table for future years.
So at least you need to have the AEF table for the base year, which has all information how much of those activities produce certain amount of these commodities, how much they consume, import, export. You should have a big table with all this information. Maybe you saw that AEF table yesterday presentation, right?
Yeah.
So we produce this also for the future years. PECAS produce this for the future years. These are the values for the AEF table for the future years. But we are not using it for any of the calibration or anything, but model calculates how much it produced, how much it used in the future years. And this technology choice file also with output file, actually it gives you, because we saw yesterday each activity has technology options, so this gives you each zone, each activity, and what is the how much amount of money they spend for each technology option. So this file, because these are the output files, we actually normally don't use these files. We use these files generally to troubleshoot the problem. If we got a problem when we run the model. EV, this is actually the option. This is actually has, for example, EV is like an average option, and this is because this is like the three options. This is average option, and this is, for example, less option, no option. Here we use this EV actually we are not used for calculation. This actually giving to the model. You have to use labor and space to define these technology options. Yes. And the last file is the zonal make use file, which is also like make use file, but we calculate the make use for each zone. So here, because we saw make use file has the make use amount for all region, but this file has the make use amount for each zone and for each commodity, how much you make and use in each zone by each activity. So here for the activity we have the numbers and the commodity numbers here. We don't have the names here, but you can get these names from the activity numbers and the commodity numbers files if you need to analyze these files. So these are all the output files. So it generates those files for all these years. And if you have any questions, you can ask now. And all this information, description, I don't know why I cannot access the website. Available in this website, hpaspecto.com. So you can go to that theoretical formulation, and also there is a user guide which has explanation for each variable in the files. So it has all this explanation. I recommend to read all this file documentation. It's very important to understand before you run the model, because this documentation has the description. I have in my system. So yeah, so all this explanation for this So this document you can download from the website, and it has all the theory behind the model. You can read it and try to understand how the model works. So if you have any question, you can ask any time. And also there is another document called in the website called user guide, which has the explanation for all the output files and input files. It has a description for what is this, what is this coefficient means, what is the standard deviation means. All these explanations are available in that user guide documentation. So I recommend read these documents, so then you will get a better understanding. I know it's very hard to get an understanding the first time, but if you read it and you run the model in the second time, you will get more familiar with the model. So because you can get familiar with all the outputs and also with all the inputs.
So can you another question? Say if I want to build a new model for my city, like Guangzhou, how can I start this work? Like how can I prepare the data or information or something?
Yeah, the main data set, main actually information we need is input-output table, which is the AEF table.
AEF?
Yes. Which we call in the most of the economics guys, they call it as an input-output table. For a region, most of the government agencies, they have for each activity how much they consume, how much they make for activities and commodities. For example, agricultural operations produce agricultural products. So agricultural operation is an activity. Agricultural product is a commodity. So these, I think central bank reports, I don't know, bank reports of this information normally available for all the regions. So first of all, the main important data set is that one. So after that, you need the census data, which has the population data for a region. For in each zone, how much population, how much households you have in each of the zones in your region. And another important data source you need is the place of work data. How many employees are working in each zone? Most of the time, those information is also available in the census data. And those are the three main information you need to start the model. Very simple model.
What about land use data?
Land use data is also very important. If you have the three main inputs are those ones. But if you have land use information for each region, which
we got transportation model.
Yes.
And we got land use data for each zone, each TAZ.
Yes.
So I know I want to how to use this data.
Yeah. So land use data you can use to generate the floor space quantity file, which is a floor space I file, which is also an input to the model. So you can use the land use data to find out how much space quantities available in each zone. So you can give this information as an input to the model. So
you say this floor space
I
input.
yes.
Is just for the base year or for every forecast?
We need it for definite for base year. Then ST module can calculate for the future years.
How to? I mean, it will calculate from the base year.
Yeah, it calculates using the base year floor space.
And like for example, the 2026 in this demo. So the 2026 years floor space is generated from 2025.
Yes, base year. Because every time that these functions, which I show you, so these functions calculate the factor you are going to apply in each zone to increase the floor space in each zone. But it's important to you have the base year floor space. So because you are starting from that point, you need to starting point, which is your land use data.
So I used to prepare the land use data in the form of the 2025 file folder.
Yeah, floor space side form.
Floor space file.
Yeah, floor space side. Yeah, this file. So floor space side files.
Got. Yeah.
So you need to prepare the data in this format.
This form, every TAC has.
Yeah. Every space type.
Constraint.
Yes. Constraint.
The
Yeah.
constraint is given in the total.
Yes. Yes. You can define the because land use data give you the how much space you can develop in each zone, right? You cannot develop 100-story buildings everywhere. You have limit in each zone. So we can actually modify this equation to limit the development in each zone. Yeah, we are actually still in the progress. Still in process to constrain that floor space quantities in the Wuhan model. but we are going to apply that limitation to the ST model. But you are right, we need to add this constraint to the ST model.
How do you do we need to define the constraint for each zone?
Yes.
Each zone has
Each zone for each flow space type.
Yes, you
so
can
which is for flow space type.
you can define the file same format. If you can define a file which has the maximum quantities, we can use that file to limit the maximum development.
In this demo, is there?
No, this file is not available in this demo because we are still in the developing that model, the ST model for the Wuhan. It's still we are progressing, but we are going to add that option.
And now it doesn't have the constraint.
But it's easy process. I think we just need to change the script, but we are still developing these input files for this constraint. But the model has a capability to do that, but it's not available in this demo model.
So if I got this constraint file in this form, how do I get it into the model and let it work?
Yeah, you need to prepare it to this format.
Yes, and where do I put this?
You need to put it into all years input folder.
Into all year, every year.
Yes,
every
because
year.
it's not going to change because it's a fixed amount for all the years. Because you know maximum is not going to change, right? You need to put it to all years input folder. So we are actually, then we can change the script to read this file.
Like we put SD parameters here because each develop rate will be the same for the even 10 years. So you can do the same thing here.
Yeah.
Sorry, can I interrupt? What?
It's already 3 p.m., so it's time for lunch break.
Great.
You worked so hard, you worked too hard, probably. 休息一下，3点了。
Yeah, interested about.
真的。